Hello everyone, this is Sean again, and today we are going to talk about behavioral modeling. Now, I'm going to be talking about mostly the first part of Chapter 6. I won't be discussing the state machines or the crude matrices, but I will be talking about the interaction diagrams, the sequence of communication diagrams. Now, very briefly, behavioral models describe the internal behavior of a system. This means how the information is passed between the different classes and the different objects within the system, not externally. Now, this is the third model that we've talked about. The first one from Chapter 4 is functional modeling, which is what a system is designed to do for the user. This is things like an ATM machine or a patient tracking system. It is, what is this? What exactly are we going to do with this system? Last chapter, Chapter 5, was the structural modeling, which is how the system is put together, the classes and the methods that were used, and basically the architecture of the system. Behavioral modeling, to this chapter, is how the system behaves, how the classes and objects of the system interact with each other, the variables that are used, and how essentially how they send these variables back and forth to each other. So, when an analyst is looking at a system, the analyst is not looking at, you've got these classes with these methods that are sending this information here, and you've got these constructors here that will make these objects that you need in order to do this. That's not what an analyst does. An analyst is looking at the whole set of use cases that we've been talking about, the problems that are being solved with the system. And they view the problem that is being addressed as these use cases that will help support that problem, that will help solve that problem. And generally, you have collaborating objects in these. These use cases almost always have multiple classes that are involved, and you're getting information from one class to give to another in order to solve whatever problem is occurring. A simple example is if you wanted to get the birth date of a patient. So you would have maybe the patient is coming into the receptionist looking for an appointment. There's a new appointment being made, and in that new appointment object is going to query the patient record object that's going to look up the date of birth, and then the date of birth is going to get sent back to that new record, that new appointment record. So things like that. That is how that is the kind of thing that we're going to be looking at here for behavioral models, is how these things get passed back and forth, and how these different classes interact with each other within the system. So for interaction diagrams, there's two types. There's a sequence diagram that really focuses on the order in which these messages get sent back and forth. So what information is being passed where, which then leads to information being passed somewhere else, and so on. So basically the temporal structure of the system. Now, the communications diagram is more about the message flow. Where are these messages going through to get from one point to another? Who is doing the talking? Who is sending information to what within the system? And so the classes have four basic parts. They have the objects, which are concrete class instances. And along with objects, you can also lump actors in that. They are different, and when you see a diagram, you'll see what I mean. But these are the actors or the classes in the system that are actually asking for or receiving the information. So, for example, like it says here, patient is a class, the patient class, and then Mary Wilson would be a specific instance of that patient class. The second one is attributes, which are essentially the variables of these classes, the information that is stored within these objects, such as the name, address, phone number, whatever, of a patient. The third part is operations. These essentially are methods. These are what the class is able to do. This is how the class is able to get or send information from itself, taking like all the information that it has with its variables and either setting new information from these variables based on information it gets from other classes or from the user. It doesn't necessarily have to be a class. It can be an actor inputting information. That would also be a form of interaction. The fourth type would be messages. These are essentially the method parameters and return values. What is being asked for? If you wanted to get, for example, the date of birth of a patient, you're going to be sending a request for that to the patient. You're going to send a method. It may not have any parameters in it. It might just be a get date of birth method. The return value then is going to be either the date of birth or an actual age in days or years or whatever. So that would be the messages that are getting passed back and forth. Sometimes messages are entire objects themselves. Like give me a new instance of a patient class, and then it'll send an entire new instance over. But that is what is being sent essentially. The messages are whatever data or other classes are being sent in between the two classes. So first, let's start with sequence diagrams. Now, sequence diagrams are illustrating the objects that participate in a single use case, and that's important. What it means is, in one particular instance of something that occurs, and I'll show you an example of this once I've explained the sequence diagram. In that particular instance, what is the order in which things are being sent back and forth? What is passing back and forth? What needs to be passed? What information is important before you can actually be sending data back and forth? There are two types. There's generic and instance. Generic shows all scenarios for a use case, and that can be pretty big. Instance diagrams show a single scenario, an instance, if you will, and that's what we're going to focus on for this. So the sequence diagram, some of these will be pretty simple and similar to what you're used to. An actor, the little stick figure, that's the person that's actually using or getting benefit from the system. You can think of that as the person at the ATM, the user of the ATM. In this instance, we're going to be talking about the receptionist and the patient that are trying to make an appointment. These are the actors. These are the people, the users of the system, the people that will be either inputting stuff into the system and dealing with it, or who are getting the benefit from that system. The patient would be getting the benefit. They're not actually inputting information, but they are the ones that are getting their appointment put together and all that. So those are actors. The object are the classes. These are the actual parts of the system that are going to be involved in this particular use case. And you'll see again when we get the example in a couple of slides, you're going to see how these things get defined. It's important to remember to note that an object is an instance, a specific instance of the class, and as such, when you put an object into a sequence diagram and also in a communication diagram too, you are going to have the instance name first in the rectangle for the object, followed by a colon, followed by the type of class that it is. So for example, you're going to have a patient name, then you're going to have a colon, and then you're going to have patient if it were a patient class. It's an instance, that particular patient, of a patient class. The third item is a lifeline. The lifeline, this is basically the life of the object within this particular use case. Everything we're doing is inside the single use case. It's important to remember that. So if something lives beyond the length of the use case, well, that doesn't matter. The lifeline is only specific to this particular instance, what's happening right now. And at the end of a lifeline, when I'll skip down here, at the end of the lifeline, when you are done, when an item is being destroyed for whatever reason, through free up memory, or it's not used anymore, or we're deleting something, you're going to put an X at the end of the lifeline to signify this lifeline is finished. A couple of the other things that we'll have in here are execution occurrence. This is really this is how long that this particular instance, this particular class, is actively sending and receiving messages. Now, once this is done sending and receiving messages, that execution occurrence will have finished. That doesn't mean the object is destroyed or goes away. The lifeline might stay. That object might stay in memory being ready to be used for something else. But this particular moment when this information is being sent or received, that execution occurrence exists, and that's the length of it. Again, this will make sense when you see the next slide that gives the example. The message itself is basically an arrow, a solid arrow for a call, for a method call, and then a dotted line with an arrow for a return value. So I'm asking for the patient's date of birth. That's going to be a solid line going to the record that has that, and then that record is going to have a dotted line return value with the actual date of birth that's going to be given back to the appointment or the new patient record or whatever was asking for it. Now, a guard condition, this is really a requirement. This is what has to be done before the message to be sent. Think of this as an if statement. If something is true, if this condition has been met, if this is true, then I can send this message. And that's essentially what it is. And that is essentially how you would code it as well when you get to that point. You would be coding an if statement or a while statement. There'd be some check, some logic check to make sure that something was correct or true before you sent the message. And then finally, the frame. The frame is really the context. The frame is the use case. The frame is what we are worried about in this particular sequence. And so let's go to the next slide. You'll see what I mean. Here we have a make appointment use case. So that frame is make appointment, and that's all that we're covering here, the instance of the specific instance of making an appointment. So you notice along the top, and this is where you should be putting actors and objects. You see the actors, the patient, the receptionist, and these are instances of. So notice it's a patient and a receptionist. It's not just some abstract or generic actor. It could be anybody. No, it's these particular people that are doing this. And then for the objects, you have the patient object that maps to a patient, right? This is the concrete patient object in the system that is a patient's object. You have an unpaid bill, which is just, let's see if there is an unpaid bill. This is, again, a class that could be involved in this particular use case. And then there's the appointment class, which is what we're trying to make based on this patient's information. So as you can see, as we work our way down, you can see the lifelines for each actor and each class. They go from top to bottom. They essentially span the whole length of the frame. And then the execution occurrence for the patient and the receptionist, these two actors are going to be involved in the entire length of this interaction, so their execution occurrence takes the entire length. The patient record is only taking as long as it takes the receptionist to look up the patient record. So the receptionist will type into the system, look up patient, and then it doesn't show it here, but the patient would essentially return an instance of itself to the screen. We don't have that system set up, but it would return an instance, and it would say, here, this is the patient that you're looking for. And then once that's finished, then you don't access that class anymore. You only needed it for that beginning to find that patient in the system. And then the next thing is the receptionist is going to, well, not the receptionist won't do it. In this case, it looks like it would be something that would be done automatically. It would show them if this was true. Are there any unpaid bills? The receptionist will see if there's unpaid bills. Again, the unpaid bill object would be fairly small. That class would only be used to return a value of yes, there is, or no, there is not an unpaid bill. Now, at that point, once the receptionist knows that the patient is in the system, the patient doesn't owe them any money, so they can actually work with him, I guess. They would then, the receptionist would ask the patient for what time do they want, and maybe get a list of appointment times. So what's happening in the left side after a patient exists, the new cancel, change appointment, and the appointment times, these are actually methods for the system and that the reception needs to enter. But the receptionist needs to get the information from the patient. So these are actually, these are real people, but it's the same idea that you have a method that you're asking a patient for the information that's then going to get put into the system. So that's what these are implying, that the receptionist is getting information from the patient. So then after the receptionist has gotten that information, the match appointments method essentially is called, and she looks to make sure that the appointment times are good, that there are no appointments, there are no appointment objects that contain these specific times, and then once there's a time that's available, the receptionist then creates the appointment. Now notice, there are two very short execution occurrences under appointment. The first one is just a call to see are there any appointments that match the time that I'm looking for, and if there are, okay, then I can't create an appointment then. I need to find an empty one. And so it's very short. It's really just looking for specific times. And then the second execution occurrence is really just creating the appointment. It's making a new appointment class object and then creating the appointment. So the idea then with this is that you can see the sequence of events that occur for the make appointment use case. Starts out with the patient at the very top requesting an appointment, the receptionist looking them up, making sure there's no bills, receptionist getting information, receptionist then checking for available times, and then creating the appointment in an available time. That is this particular use case. It involves both real people and the objects inside the system, the classes. So very briefly, some best practices, I guess, for creating these sequence diagrams is first you set the context, which, I mean, on one hand is very simple. You draw the box, right? But it's also defining what use case are we going to do? What are we trying to find the sequence of here? So setting that context, setting exactly what it is we are trying to map out is the first step. Then you identify the actors and the objects that interact. Sometimes there won't be any actors. It's just going to be an automated thing where it's just classes. Sometimes there's going to be one actor, just the user. Sometimes there's going to be, in this case that we saw before, there's multiple actors. So identify those and put those at the top going across, just like you saw in the diagram. Then you set the lifeline for each object, and that really is just a dotted line that goes straight down throughout the entire length of the frame for all of the objects and actors. Then you put the messages in, because now we need to know what we're going to be passing back and forth before we decide how long any of these interactions are going to take. We need to know what we're going to be sending back and forth, and the order in which they are. The later they are in the sequence, the lower they are in the frame. You can include any parameters that you have in parentheses if you are sending a parameter before you get the return value. Put those in the sequence diagram. So if we back up here, you can see all these methods, they have no parameters. They're just methods that they're asking for information or getting something in return without giving the information to the other object. But if you are going to be passing a parameter, that's where you would put it. And then any return values that are really obvious that you don't need, like for example, sending a new instance of an appointment class, you don't need that because that's not really that's not adding any information. If I say create a new one, I don't need to see the return value of a new one being created. That's obvious. It's only when there's a return value that's important to the rest of the sequence that you would show that. So finally, once the methods are done, now you're going to add the execution occurrences for how long these are going to be active, how long these objects, these classes are going to be active within this sequence, within the interaction between the different classes. And then finally, you're going to validate. And you have to validate for all these diagrams we've been talking about. And at the end of the lecture, I'll give a brief overview of validating for sequence and communication diagrams. So speaking of communication diagrams, let's go on with them. Communication diagrams are not so much about the order in which things are. That's what the sequence diagram is for. These are more about the dependencies among the objects. So in other words, they have the relationships, like which objects are going to be talking to which other objects. So we can set up specific channels for them to communicate with, whether it's directly communicating or whether it's going to be through some sort of intermediate I don't know, some sort of class in between that does the communication for these objects. And that depends on the system and how you're going to set it up. But that's what the communication diagrams are for. They're going to help us show where the data is going, who the data is being passed to and from, and the relationships, the sum total of the relationships from one object to however many it would have. And again, this will make sense when you see it. So the syntax is pretty much the same. But instead of being temporal, we're not going to have things like execution occurrences or anything. Instead, it's going to have the associations between the two classes. So it'll be a straight black line with no arrow between the two either actors or classes that communicate, that send and receive messages from each other. So in other words, if there's no time that these actors or classes talk to each other or communicate to each other, there will be no association. Otherwise, the rest are essentially the same. And so here is a sample communication diagram. As you can see, the patient and the receptionist, actors, communicate to each other. There's an association there. The patient doesn't reach over the receptionist's shoulder and then start typing things into the system. No, the patient just gives the information to the receptionist. The receptionist will ask questions to the patient, and then the receptionist will be the interface that will then enter information into the system. Which is what we're looking at here. It's why you can see the receptionist has associations with all the classes, but then the patient does not. The patient has no direct connection to the system. However, the patient still is a stakeholder in the system. The patient still does receive benefit from the system, so they are part of the use case. And then also notice the direction of the messages are listed along with the messages themselves directly above the individual associations. So again, some more best practices for communication diagrams. Set the context. Again, set the use case that it is being modeled here in the communication diagram. Identify the objects, actors, and associations between them. Now, this is different because you need to identify the associations, but that makes sense. That's what we're talking about here. That's what we're trying to display, is the communication between the different classes. Then you lay out the diagram. In general, you want to lay it out left to right, and in general, you want to keep objects that communicate to each other close together within the diagram. So as you could see in the previous example, the patient in the diagram is nowhere near the objects from the system. The only thing the patient is close to is the receptionist, because that's the only object or actor that they have an association with. If you keep like classes that have similar communication methods close to each other, you'll make it a lot cleaner. The diagram will be easier to read. Also, you will avoid having associations cross other associations, which is a big no-no. You're really not supposed to ever have associations cross each other in one of these diagrams. So then once you have the diagram laid out, you're going to add the messages back in. So if we look up here again, once you have it laid out, once you have the actors and the objects, and you have the associations, then you put the messages themselves on top of those. And then finally, you want to validate the model, like I was saying before. And so speaking of validating, let's talk about how you validate behavioral models. For the most part, these are similar to the other kinds of validations. Actors need to be consistent between models. In other words, if you have the patient and the receptionist in the sequence diagram, you're going to need the same patient and the same receptionist in the communication diagram if you're talking about the same use case. Every use case needs to be consistent with all of the actors inside in the use case. Messages on a sequence diagram have to match associations. In other words, if you do not have association between two classes, then you can't have any messages between them because there's no association. They don't communicate. So whenever you have messages between objects or actors, you need to have an association there. Also, any message that you have in the sequence diagram needs to appear in the communication diagram. You need to make sure you're modeling all of the communication necessary for the use case. So they have to have the same number of messages and the same messages. The fourth point, guard conditions need to be in both diagrams. If you have a guard condition, if this communication cannot happen until x equals 5, then you need to have that in both the sequence diagram and the communication diagram. So they know that association is only valid when x equals 5. Or x is greater than 5, or whatever your condition might be. And then the last validating point for the behavior models that we've talked about is that the sequence of the messages, I mentioned this before, they need to go in order, chronological order from top to bottom. The first message is on the top, and then subsequent messages, as they work their way down, go down in the page until you're at the bottom of the page. That would be the last message that would be sent in this use case. Okay. So it's very important. It sounds obvious, but it's worth checking and validating, because you'd be surprised when you do a number of these that you end up with things that aren't necessarily in chronological order, and that you'll need to go back and just verify that. That's why we call it verifying and validating. So that's it. The last 2 points we haven't talked about. We didn't talk about state diagrams. We didn't talk about crude matrices. So that would be it for this. For these models that we've talked about, for these diagrams. And that concludes the brief lecture on behavioral modeling. Specifically, I just want to go over again, we talked about interaction diagrams, the sequence and communication diagrams, and about behavior models in general and how they describe the internal behavior of a system, that how the pieces of the system, the classes and the actors in this system interact and communicate with each other, how they send messages back and forth. This is what behavioral model covers. So everyone have a good week, and I will talk to you again soon.